So for related rates problems, an important thing to do is just draw a picture. And you're always trying to make a shape out of it, usually a triangle or like a sphere or something. You're trying to make a shape so then you can apply a mathematical equation to solve it. So let's see. A 6-foot tall guy walks away from a 15-foot tall light at a rate of 5 feet per second. So what can we draw? We can draw a 15-foot tall light and a 6-foot guy. So we have that. So how would we make a triangle out of that? Well, if the light's shining down on him, that means his shadow is going to be right here. So if his shadow is right here, then we can make a triangle out of that. So this guy, this length will be 6 feet, and this length will be 15 because that's the lamp's. So the next thing is to label everything that's changing. So what's changing? So right here it says when he is 10 feet from the pole, okay, 10 feet, so this will be 10. How fast is the distance from the base of the pole to the tip of the shadow, right here's the tip of the shadow, changing. So we can label that y. You can label it whatever you want, but I'm going to say it's y. This is x because he started from the base of the pole and he's walking away at 5 feet per second. So this is going to be x. And all I did here was redraw what I had already drawn, but just as a simpler image. So here, this is the lamppost, 15. This entire distance is going to be y, because that's what we decided here, from the base of the pole to the tip of the shadow. So that's going to be y. And then over here, it's going to be 6, which is the guy's height, and then y minus x. So y minus x, that's because the shadow length, this is the shadow length, so that's going to be this distance subtracted from this distance will give you the shadow. So that's where that comes from. And so, yeah, an important thing to realize is even though this says when he is 10 feet from the pole, this doesn't mean that x, you will write it as 10 because this distance is changing. So you plug in 10 at the very end, but if it's changing, you write a letter for it. If it's not changing, for example, the guy's height's not going to change and the lamppost isn't going to change, so you leave those as numbers. If it is changing, you leave it as letters. So then the final thing I wrote is all this information. So x equals 10. So we do that at the end, but x will equal 10 because that's the point they want us to solve for at 10 feet. The next thing is dx dt is 5. So what is dx dt? Dx dt, all that means is you're doing the derivative. So x, what is x? So x here is feet, 10 feet from the pole, right? So x is 10 feet. Because we're saying that x is going to be equal to feet. Dx dt, all that means is you're putting a d in front of the x and a d in front of the time. So that's going to be feet per second. It's just like a way of notation. Like if we're saying that x is equal to feet and dx dt is feet per second. It's just a way of writing units. So dx dt is equal to 5. And they tell you that right here. It's walking away at 5 feet per second. So now since you have all that, you decide what you're trying to find, and you're trying to find the rate, how fast is the distance changing from the base of the pole to the tip of the shadow. You're trying to find dy dt. Because right now we have y, but we want to find dy dt, because it's just a notation. Because they want how fast is it, not what is the distance. They don't ask what is the distance, so it's not going to be in feet, it's going to be in feet per second, so we need to write dy dt. Okay, so for this problem we'll use similar triangles. So all that means is using these two triangles, I'm going to set up an equation, because since they're similar, I can just write y over 15. Y over 15 is equal to 6 over y minus x. So all I did was write y over 15 and y minus x over 6. because this is just these two are just similar triangles. So all I did is y over 15 and y minus x over 6. So now since it's a proportion, we can just cross multiply. So it's going to be 15 times y, so 15y, and 15 times negative x, which will be negative 15x. And here it'll just be 6y. Now we're going to simplify it. So we'll subtract 15y from each side. You'll get negative 9y equals negative 15x. And then you can just make both of those positive, and you'll get 9y equals 15x. Now what we can do is, now since we're at this stage, we can actually solve for what we need, because we're left with y and x. So now we can find dx dt. How are we going to do that? Well, all the d means is just derive it. So 9, the derivative of 9, so that's just going to be 9 because it's a constant, and derivative of y is just going to be 1, but since it's with respect to time, it's going to be dy over dt. Here it's going to be, you're leaving 15 because it's just a number, and then derivative of x is 1, but since it's over time, it's going to be dx dt. Now it's the easy part. You just plug in the information. So all you do here is, we want dy dt, so I'm going to divide by 9 on each side, and then dx dt we said was equal to 5, so it's going to be 15 times 5 dx dt, which is 5, divided by 9, because I'm dividing 9 on each side, and this will get you 25 over 3. And remember that 25 over 3 is a rate, so it will actually be feet per second. So don't forget units. So that will be your answer. And the second part of the question was, sorry for that. The second part of the question is, how fast is the shadow length changing? So how fast is it changing? Well, what is the shadow length? We said that it was this part, because it's y minus x will give us the shadow. So what we do is just go down here. And so we said that it'll be y minus x. So that's equivalent to saying that's dy dt, because if we take the derivative of this, it'll be dy dt minus dx. So because if we say that the shadow is y minus x, we can just take the derivative of y is 1, but since it's with respect to time, it's dy dt. Same thing here, since the derivative of x is dx dt, now we can just plug in information, because since we got what dy dt was, we can just plug that in. 25 over 3, and then dx dt is 5 right here. dx dt is 15 over 3, because 15 divided by 3 is 5, so it's just that. And then you subtract it, and you get 10 over 3. Don't forget units, so it's going to be feet per second. And that's your answer. I hope that helped, and thanks for watching.